showing it as starting over here, so give me a second now. Yeah, it doesn't show it going right now. Here it goes. There it goes. It's showing it live now. For some reason, it's not showing it over here live, but.
Yep. Show.
Okay. Are you hearing me already? I'm gonna check in. Gonna refresh this page here quick, see if I can. If we're watching a chat. You can?
Yep.
Okay. I was just trying to see where this popped up if I was going to try to go to like the Tormach page and go to it. It does say it's public though. Oh, they're going to be, oh, there we go. All right. I just wanted to open this chat. I think we're good to go now. Now I can see the chat over there. All right. So I think we're good to start going now. Let's double check in here. Am I not showing up on the screen? Okay, yeah, I forgot a little bit of a delay there. So we're making these toe clamps here today. Little 1032 clamps that I've used for different stuff in the past. I've always made a few like different models. Try to show them up here in the camera. And in the past, I've just kind of modified them to the sizes and everything that I need. So I got a different design that I'm trying to work with today. That's kind of like a countersink that's going to be using like a flat head screw in it instead. Just a little bit different than the ones I've had in the past. So I got my stock over here for it and all the tools that I'm going to be using. Got my first tool set up in the machine already. So we're going to go about just kind of, we're just going to do one right now, and then we're going to kind of talk about the process and the setup, and after we just kind of get one going and show them that. And then we got the camera in the machine, so we should be able to show the machine running, the full tool changes and everything as we go through the process of it. So right now for my zero, I just got it over here on the left edge of the vise. I'm just lining my part up with this wall. It's not the most ideal for a hold, but whereas what I'm doing, it's sufficient enough, so I'm just going with it for ease. So I am giving the part a good lock because I am just holding on to two saw cuts here. So the first thing the part's going to be doing is it's just going to be spotting. So it's going to come down, the spot drill is just going to put essentially like 3 countersink little spots into the part. So just making sure I'm on my right program here. And then we'll have the full simulation, being able to watch it over here on the screen as well. So that's all that part does, or all that tool does. So we're changing that now to the drill now. It's kind of showing how fast, even when you don't have a tool changer, you can still get tools in and out of the machine pretty fast with the automatic drawbar. So got the next tool in. It's going to give me a warning because I don't have a tool changer to switch to that tool. Got it in there. So and then this, the hole is actually going to be, or the drill is going to be drilling for the tap, and then it's going to be drilling 2 kind of pre-drill holes for the slot to kind of just give clearance for the end mill to go in and make that slot kind of just relief for it. Especially because the drill's already in the machine. It's the right size for the clearance for it, so it's just a nice one to throw in there. In the clamp system that I'm working with, like these toe clamps, they're very similar to like your standard half 13 clamping system like this, but instead of like the teeth on the back of it for the adjustable height, you actually would be putting in, like on one that I got complete here, you would be putting in different adjustable screw sizes here that would give you a different height reference for being able to use it as a toe clamp. So the drill's done running. Next tool that's going to come in is going to be a tap. So we are using rigid tapping for this. Going to give me my warning for my tool change again. And it's only the one hole that actually gets tapped. Because then we're just cutting the other 2 holes, like I said, are going to be like for a slot. That one's done. And I do just know the tool order that I need to put them in, but again, it's still going to always give me my warning here for once it's making a tool change. And it's going to give me the actual label of the tool and the description of it to make sure I'm putting in the right one. So in this feature right now, the tool is actually just ramping down it. And you should be able to see it here in the simulation if I move my view here. It's showing an angle tool because I didn't set up my tool description correctly, but it's still just showing the center tool path and how it's ramping down. And then this tool is going all the way through the part, so it's going to go past it just a little bit. It does a little bit slower for the finish pass around it. And the next tool, a lot of times you would face the part first before doing a lot of that stuff, but because this tool is actually profiling the outside and just the order that I chose to set up to do it, it's actually coming in, this tool is going to be facing it and then profiling the outside of it. And I could always change that to the front of the program, but it's only taking a minimal off, like 5,000 off of the face of the part, so it's not really affecting any of the other features that get done before it. So again, it's going to give me my warning. So it's going to do its face pass, just kind of some parallel step overs. And then once it's done doing that, it's actually going back into like a ramping path for going down and around the part. And I got it going like 160 inches a minute here for this one. And same thing, it'll slow down a little bit for the finish pass at the end. So again, it shows the ramping here as the tool is going down. And then it gives you a nice visual of when it gets to the bottom, so when you know it's going to be there. Then it does that slow pass for the finish. It's going to come up. And then the last feature that's going to get done is just going to be a chamfer on the slot around the outside of the part, and actually on the 1032 it puts a little bit deeper chamfer on it just for like a lead-in. And then I actually end with this tool because then the first program or the first tool of the program is the same tool, so then like essentially when this one's the last one, it also works for just keeping it set up to run the next part. So let's give my tool change there. And that is actually the completed part. So then we're just going to take that one out. Blow it off, get the coolant off in the machine. So a part over with the dump part, grab a new piece of stock, throw it in. And like I said, this is actually the first tool for the program, so we can just go right back to cycle start. And essentially that's the process for running it. I'll go show some of the setup and actually like how I was setting up the tools and stuff like that and what I use, because I don't have like I don't have our electronic tool setter in this machine, so I'm actually using a manual one. And I'll pull that out here in a second. We'll just get another part here running. Drill cycle takes a little bit more time, and I could always speed up the drill cycle. I meant to kind of take out the cue and just have it do a straight plunge, but it doesn't hurt to leave it as a PEC cycle. It just adds a little bit of time, but it's essentially a safer cycle. Oh, okay. I forgot about the delay there for a second. Thought my camera wasn't working. So, and something that these clamps will actually work with too is our excess tack. The reason I'm making 1032 specifically is I'm going to be making some 1032 T-nuts later for my 440. I have a bunch of 1032 clamping and screws of different heights for stuff that I always used in my fixturing in the past. So I'm just trying to make up a bunch of new different types of functions and features that will work along with all the other stuff and hardware that I already got. And that's the nice thing about having a machine like this and being able to just make, you can kind of make stuff to the custom fit that you need it. A lot of times where if you're going to go buy a clamping system like this, it has to come as hardened steel, which that's like not bad, but for what I'm doing, the purpose that I'm using it for a lot of times, just using the aluminum is completely fine and like is good enough for what I'm actually using it for. So that hole got done, the drill got done drilling. Oh, don't know why I actually pulled the part out there, so because I wouldn't be able to reload the part, that was just an operator mistake, so if I would have went to go load that back in, I could probably roughly get it in there to do the outside profile and everything like that, but essentially if I went to go run that tap now, that'd probably be a bad part and wouldn't line up without some way of accurately locating it again. So I'm just going to put that one to the side and just run another one for that. I just got ahead of myself with it. I meant to pull out the tool and actually pulled out the part instead. We're just going to load another one in there. But now we're going to have to go back to our tool one again. Because like right now, how I'm loading my parts, I'm just eyeballing them with the left edge of the part. So like, if I would have had some type of hard reference stop, I might have been able to like reload that part in there and get the tapped hole to accurately line up. But for right now, with the stock that I'm using, it's just easy enough to load a new part. Start my program over, telling me to make sure I put the right tool in, and now we're good to go again. So, and after this part's done running, I'll show how I'm actually touching off tools with, this is an option that we sell as well for being able to touch off tools where you can kind of use an indicator face and set that as a point of reference in your machine, kind of bring all your tools there, set them as 0, and then just be able to use like the Heimer or a probe to kind of set the 0 of your part, and all of the tools in your machine that you have already touched off to this will then be referenced. So changing out my tool and not my part this time. And so in this model, and something that we're going to be doing after the live is done, is we are going to be trying to get this model and the program that's actually running in the machine in the description for people to be able to use and make this part if they would want themselves as well. Just looking for my Access Tech T-slot thing really quick here. Not sure where it went. I'm gonna change out the tool. Trying to look for a little Access Tech T-slot to reference. I can grab one here in a second. Wanted to be able to show it. So as my slots running, I'm going to just walk away for 2 seconds to go grab that. Feel free to ask any questions if you have any questions about the setup or any of the tools that are running or feeds and speeds. Again, we will be trying to get the full program loaded up for everybody to reference later as well. But if you have any questions on the fly, feel free to ask them. Sorry. Tool in there. All right. Got what I was going to reference here now. So this is this is essentially like a sample of the T-slot table that we use for our XS Tech. It's just like a replica of it. And so a 1032 dropped one. These little 1032 nuts are your standard 1032 nut. Oh, maybe was off of the camera there for a little bit. So over here, these little 1032 nuts go into the T-slots, and they work like essentially right off the shelf that you could get them, and they'll fit in there. And so the idea would be, if I grab the toe clamp that I had out here already. So you'd have to put down a piece of material or something like, if you had something like this one, and then you had a screw. Just gonna kind of reference this here. Essentially how this toe clamp would work then would be, making sure this gonna show it up on camera right. So get a good contrast there. So as you screw it down here, it's kind of holding it down, and then the screw end over here would be your adjustable height. And then, so this would work in the XS Tech, and then I'm going to make some T-nuts that work with a 1032 hole for my 440 and stuff like that, and just kind of have versatile work holding that can be used for multiple machines, or even a base plate, you could tap a hole into it and just use it on there. You don't have to necessarily use it with a T-slot type of setup. So my slot got done in there. Change out my tool. I'm trying to get a quantity of these run. Got a little quantity here they're going to run through. If we do get through the quantity that we have before the end of the live, I'll go start setting up the Op 2. The idea with how I got it set up is for Op 2, I'm going to still have to set up like a stop over on my X, but then essentially it'll be able to run the same program, but I just won't run the drill or the tap. I'll just have to run the slot, the outside profile, and then the chamfer on it, and I should just be able to match it on the backside for what I'm doing. Where you could have, like, you know, cut it farther than you needed to and kind of just hold on to a minimal amount, but I'm just trying to work with the stock that I have and everything like that. So if I essentially would have wanted these to be a ½ inch thick, I would have needed some type of setup where I would have, you know, cut through the side and cut in the jaws or something like that to be able to do it. Back in. And we could even try to run the next part just at like right on the screen here. We could just like go and increase the feed rate, and I'll try to go one at like 125%, one at 150%, and just see what we get for it. That one's done. So, and then for this next one, I'll go up the feed to 125%. And then we should be able to get a point of reference. So it says it is like a 6-minute part right now, which is kind of long for that. And like I said, there's definitely room to speed up what we're running on this right now. But a lot of times it's about how conservative you want to be for saving your tool wear and stuff like that as well. But we got a pretty good hold and everything like that, so we should be able to cut it a decent amount harder without any problems. Got the right tool in there. Drill in there. And these are just the standard clamp that I've used for years and everything. And like I said, they kind of follow your ½ the principle of it. They're just very versatile with being able to just put a different screw size in it and everything like that. Or screw length. You're using the same screw size, but adjustable screw length based on the height of the part that you're clamping onto. Or you could, the reason I designed it kind of with the hole like right in the center, you could essentially just use it as like a bar clamp over something and just go right over the middle of it as well. So it seems to be running completely fine at 125. Again, we'll run this part at 125, crank it up for the next one, see what we get for like a speed difference in the run time of the part. Oh, and I just, for some reason, unlocked that one again, so I'll have to start that one over. That's sometimes going in between different stuff, you just gotta be careful about doing that and getting distracted. As long as you're catching yourself before it goes bad, it's not as bad of a mistake, since you just lost a tiny little bit of stock, and if I needed to, I could still hand tap it and make it into a good part later. But I did just make that same mistake again where I pulled the part out too soon. But again, it's more about catching your errors. Before I would have just like, you know, took that out and ran the next tool or something like that. That's where the problem would have happened. But as long as you catch it, kind of restart your program, go back over to the start, then you'll be good to go. Kind of got my tools set up in my order here from like 1 through 5, so kind of making sure I just keep them set up in the order that I need to grab them. Actually, the little liner I got here, it's just, they're like little liners for steps that I got like one winter for, they're supposed to be like for stopping slipping on stairs. But I just like putting them on the edge of my tool benches to stop stuff from kind of like rolling around. Maybe after this program runs too, I'll take out that, I'll just turn that drill into a G81 cycle so it just kind of straight plunges through the material. Should be fine for that. Or even if I turned it into like 2 pecks instead of like 10, how it's doing right now. Would still speed it up quite a bit. Let's see, should control my tab speed even if I'm at higher feed rate. Let's find out. Yep, it does. Alright, wanted to make sure of that. Get that tap out. Run my slot, see how this runs a little bit faster. Okay, that's moving kind of nice. Going down there is pretty fast. It's like 86 inches a minute. And we'll have the speeds and feeds posted for the 100% feed rates. But then, like I said, how I'm kind of talking it over on here, we're going to be showing kind of where we can push it up to with the increased feed rates and percent numbers. So again, this is all still at 125% from the previous parts we've been running. And 125%, like, so if you're going up 25% in feed rate, that doesn't necessarily mean a 25% in increased time on the part, because a lot of the rapid speeds and stuff like that are going to be what's actually affected. Yeah, it's cooking around there nice now. It's at like about 200 inches a minute when it's ramping down there. Chamfer thrown in. And this is something I would always do, like prototyping kind of in the past, is like I would always start my programs fairly conservative, and then if I needed to do like a production run in an increased quantity, then I would like increase the feed rates and everything over the time. So it's not a through spindle coolant. It is just a programmable coolant nozzle that I got just spraying on the one side. So it's our Smart Cool system that is an adjustable coolant nozzle for being able to kind of spray only on that one side and have just one stream going. And I kind of purposely have it hitting a little bit low right now for like, cause where I got my camera set up over in the corner here, I tried to get it to like avoid the splash up and everything like that. So I kind of purposely got it set a little bit lower than ideal right now. So that part's done. Yeah, it's the Smart Cool system in there. So kind of a glare with all the light and everything like that. Can't get a full detail on it. And it's kind of, let's see if I can just bring down my spindle here. I think it'll be kind of hidden behind the spindle with the camera angle too, so I can't kind of really see it over there. But yeah, it is just a Smart Cool system. Yeah, I should be able to. Oh yeah. Well, that one's hard to. I don't want to adjust that because of how I got it. It might fall. That's kind of. I was gonna move the camera in here, but the camera I got at the machine is kind of not an ideal rig up right now, and I'm just kind of worried about getting it back in the same spot if I moved it right now. But here, I'll just try it really quick. It shouldn't be that hard. Just make sure I can stretch it here. All right, so. Make sure I don't get a delay here. Oh, I think I just unplugged it and delayed lost that camera feed now. So that was what I was trying not to do, so give me a second. Yeah, I'll be able to reset that. Give me 1 second to just reset that camera feed here. Okay, I think I actually lose it here. Making sure it's all plugged in and running here. There we go. And we got that camera back. Give me 1 second to reframe it. Sorry about this. We're getting it fixed in 1 second. Let me just get it framed back up again here. Sorry, it came unplugged and I had to reset it all once it comes unplugged. So let's see if we can get Smart Cool. There we go. That's what we were looking for. So yeah, it is just that Smart Cool system over there on that side of the machine. So let me just try to get this back in its place again here now. And then we'll be good to go running again. Let's see. That looks like a good angle there. I think we're good to go. So what did we, so that last one only went down to 4 minutes, so we did actually get a pretty increased feed rate and time over that last one. So let's just try to reset another one here. We'll go up to 150, see what we get. Reset our program. Drill put in, and again now we're at 150% from the feed rate from what we programmed. And I'll be able to reference Fusion here in a second to show the part and the model that we actually got in the machine. On our drill. that might be actually something in OBS with that delay also for in the future, might be able to monitor. And yeah, it's our standard, the 5-inch vise that we're using as our work holding right now, and just using normal hard jaws with a parallel setup for the height that we got in there for our workpiece. Seems to be running at 150 just fine, so as long as these next tools run fine at that, we'll go up to 175. And so the machine for increasing the percent maxes out at 200. So we'll keep going all the way up to 200, and if we wanted to push it past that 200%, we would have to go like increase the feed rates in the actual program. Any reason to spin it? Give me 1 second, I have to move this little. Oh, like when I insert it, I honestly, I don't know, that's more of just like a habit to make sure it's kind of like locked up. I don't really have a real rhyme or reason to like kind of, if you're wondering like how I just like kind of do that little spin as I put it in, sometimes I would even do that to just kind of check the run out manually, like just by eye as a quick visual check, but it's kind of just been a habit from like maybe just like an OCD thing really for loading a tool when I always do that when I put them in. No real rhyme or reason to it though. So here goes our tap. That one seemed to go fine. So it's really the next two tools, once I start increasing the feed rate more and more, that are really, I mean, if I push the last tool, or the 3/8 end mill up to 200%, that's actually going to be at the max feed rate of the machine. So this thing's going about 105 inches a minute right now. It's kind of ramping right down through the material. No, yeah, it's just a fun little thing to do, right? Sometimes I don't know, like maybe just in my mind I'm checking too to like see if it like is catching or something like that, and just making sure that it feels like everything is spinning right by like a manual feel just from setting up so many tools. So this tool should be going pretty fast now when it goes to do the profile. I mean, even the facing, or no, the facing I forgot, I slowed that feed rate down a little bit. So here's where it's kind of cooking. So right now it's going at like 240 inches a minute. And the reason I'm doing like a step down instead of like an adapter from the outside is how I actually cut these pieces on the saw. I was also manually eyeballing them, so they're not super, like they're cut parallel on the saw, but how like wide they actually are kind of varies a little bit. So if I tried to program it to like say I had a certain amount of stock on each part, one might come in there and might be a little bit extra rough, and it might grab that and take a little bit more than I want to. Where if I'm coming down from a ramping, it'll essentially, I could take the full width of the tool and be safe, so no matter how much it's off, it's still going to be like a safer type of cut. So that looked like that just ran fine. So I'll get our chamfer in there. And something I am noticed, like as I'm increasing the feed rate, you will start to notice like a surface finish change like on the part, like at the end you'll kind of feel like a little bit more steps and everything like that. But again, for what I'm doing, the surface finish on the part is fairly irrelevant, so it really would be trying to maximize the speed of the part as you can. No, if it does do something like priming the encoder, I would have no idea, so. And I guess I could leave that tool in because that's the first tool. So that one all went, and yep, feeds a little bit, or the time's a little bit down, so we're gonna go back up to 175 now. And this would be a way of, like I said, you can always just kind of start for increasing your feed rates, kind of see, like right now I essentially know that if I run all these tools at 200%, I could go back over to Fusion, and in my feed rates in Fusion, just, you know, double all my feed rate numbers, and then in the future, just run the program at 100% and know that it should still be fine. So we'll go to 175. Got my drill. Still fine for that. I just forgot to change out where I said I was gonna like increase the pec for this drill, which I can still do. It's only doing like what is it, like a 50,000 pec, which is fairly light and conservative. But again, it's more of just, it's safer, but you can definitely speed up the time if you like kind of change that. Door switch, or what do you mean force switch? Sorry. Yep. So I can actually go through the holder that I'm using right now. So right now, this would be my first tool. It is actually just a solid holder for a 1/4-inch tool. So I call them set screw holders as well. So it's just your standard 1/4-inch bore for 1/4-inch nominal tooling, and then a little set screw holding it in place. And that's what I'm using for my center drill, and this is also, my center drill is actually what it is also doing the chamfer at the end of the program. And then just because this was the second tool, I'll reference it. I am actually just using like a drill chuck for my drill, and what I'm doing, use standard BT31. It's a keyless, so I would just be able to unlock the tool by hand if I needed to right now and put a different size drill in there. For my tap, I am actually using just an ER collet that is essentially just, it was the closest nominal size. That is not an actual tap collet. You can get tap collets that have kind of a square insert that will engage with it, but this is just a standard diameter. I believe it's it's a 4 to 5 millimeter collet to hold a 1032 cut tap. And then my last two would be, again, your standard ER collet for the 3/6 mill that I'm actually using. And this could be a solid holder. This just happened to be a tool that I had set up at the time. And then my 3/8, I got another solid set screw holder for that one. Oh, so how I'm activating the drawbar, let's see if I can probably bring it down and actually show that here in the camera. So give me a second. I'll just reset out my program here too. Just gonna try to get it into the camera range. So there's actually a button right here. So if that's, yeah, let's see if I can go down just a little bit more without having to move the camera again. So it's actually right here. As I push that, it's essentially like right now, I would be able to like take out the tool or put in the tool as I'm holding the button down. And then as I let go of it, that's what would be like locking and pulling the tool into place. So like for aluminum and the rigidity, it's kind of less critical for what I'm doing. I have had experience with like heavy roughing and steel and like on machines with like heavier horsepower and stuff like that, where you could actually get like chatter with the ER collets, and sometimes the solid like holder had certain performance like that. Typically, from my background, I've pretty much just used ER collets for the majority of probably 90 to 95% of my tool holding, just based on the shops that I've been at and what I've been at, and it's always been something that works. It's not saying that it's the best. You can get into like hydraulic and shrink fit holders and stuff like that, that like really step up your quality. Like for for total indicator run out and stuff like that and the accuracy of the tool, your ER collets are going to typically be a little bit more accurate than your solid holders normally. But then your solid holders are going to be more of like a budget, kind of cheaper, where if you need to just get a bunch of holders for all your standard, you know, nominal size end mills and stuff like that, it could be, you know, plenty good of an option as well. And then maybe having some more high quality ER collet holders for your finishing tools or something. I am not you should, so I'll say it this way, you should always, like, essentially ER collets do have a torque standard that you should be using a torque wrench to set your tools. I have set tools a lot, so like in the past, and I do still set them manually without a torque wrench at times, but you can essentially, if you're not setting them to the right torque, you can be damaging the tapered surfaces and stuff like that if you're not using a torque wrench to set them. I'm just going to get my tool or my program back to where it was. Give me a second here. Okay, there's that. Should be able to start it right there. Just because I'm starting a program in the middle of a program, I'm just going to like verify it's going and doing what I want it to do and everything. Insert tool 3. Okay, got it. Should be good. So again, and for taking out the tool, that button that I was showing, if you can kind of hear the sound effect, I do it in the speed that I like do it in. I'm just going to go do that right now. So button in, tool out, release the button to go grab the other tool. Button in, tool in, let it go, tool set. And now this tool is going 125 inches a minute. Yeah, essentially because of how you can imagine too, I'll try to pull out just a random ER collet. So let's see here. Something that's like a normal. So like because of the shape of this and just like the length of it kind of between my two fingers there, that's kind of the only engagement that is on the tool, where your big like standard like set screw holders, there is a lot more of the tool shank actually kind of engaged with the surface in there. So for like the really rough cuts and the chattering and kind of how that's engaging, sometimes that solid set screw holder having a lot of that surface engaged against the inside of the holder is where that performance can be better for certain roughing scenarios. And then same thing with like set screw holders, or a lot of times set screw holders will have a flat that you can like kind of use like a Weldon flat to stop the tool from pulling out, where ER collets, if you're running them really hot because of just how they're engaged, you can actually lose some of your hold, and you can still get tool pull out in the ER collet if you're running it really hot, because it'll actually reduce your holding force if you get it that hot. So just make sure I'm on my right tool. And same with set screw though, if you're trying to use a set screw without a flat, you run into that same problem where if it heats up, you're reducing that hold on it. So let's see how fast this is running when it goes around the outside now. So that's like 250 inches a minute as it's going around the outside. Or nope, it's at 270. So almost pushing to like the max feed rates of the machine on this one. So by the time we get through the next couple parts, we'll be at the max feed rate of the machine on that tool right there. Let me start blowing them off before I grab them out. Oh, I had another tool to run though. Yeah, I still run a chamfer on that one. And a lot of times I like the aluminum clamps that I make because there's been times where I'll even have to cut, like, I'll go to hold stuff on them and I'll actually cut like the face of them or even have to cut them sometimes for clearance. It's like just that enough where as long as it's an aluminum clamp, a lot of times you still just can run into it and just cut it and not actually sacrifice your hold, where if that was like a hardened steel clamp, you wouldn't want to be running into it in the same way. And also for damaging your parts. A lot of times, like, if I'm using aluminum clamps to hold on to steel parts, I'm not going to, like, dent my steel parts or anything like that, but it's still going to be plenty of holding force. Where if I'm using, like, steel clamps to hold aluminum, you got to worry about it, like, indenting your surfaces and everything like that, and you got to be kind of more careful about how it's going to be holding on to it. Yeah, that chamfer's kind of trucking now. That one's done, so we're going to go right up to 200% for the next couple parts. Where again, like I said, if we needed to push it past that, we can go do it in Fusion. And then after I run this next one at 200%, I'll go pull up Fusion, show the program, and kind of just go reference over there some of the stuff and everything. Get my new part in. Give it a good lockup. Crank it up to 200%. No, so they're actually just, so they're really almost similar to like these half 13, you know, typical toe clamps that you kind of see at your normal fixturing setups and everything like that that come with a lot of the machines. It's really a miniaturized version, and instead of the little steps on the back for the adjustable height, you would just use different lengths of screws in the tapped hole for adjusting your height on the other side. And obviously they're a shorter length, so they're meant for kind of really tight spaces, but also giving you the maximum amount of like clearance for your tools and everything like that, and not having your clamps kind of get in the way. That's kind of the purpose that they serve. And I've used these for really giant parts. I've used these for really tiny parts. I've also kind of, like I said, I had like different ones that are even like thinner, where I even like counterbore this to where like my screw head was like below the top of it to get the smallest height I could out of it. And then I had like the other one here where instead of having the screw for the adjustable height on it, I actually just like built in like a little nub to essentially make these nominal for holding on to like 1/4 inch stock, because I was doing a bunch of like 1/4 inch stock plate work. So I just made a set just to be able to work with those, and then I didn't have to worry about that screw. And then I actually got more surface engagement on something like this for kind of having it like rest on something without damaging it. Where if you have a screw head and you're clamping really hard, that screw head can sometimes like damage the surface that that's going into. So 200% drill. I still forgot to take out the cube, but we can still always do that. Might as well just control that one variable at a time, where I'm just doing that feed rate for now. And again, like I said, the program that we're going to post is going to be the 100% feed rates, but then if you're watching the video, you'll be able to see how you can kind of adjust in Fusion and increase your feed rates from there. But I always say it's a safer place to start at conservative numbers and then crank it up as you're going and kind of see the performance of your tooling and kind of control all those variables first before you run it at like the maximum feed rate. And the other thing I was saying with these clamps is if you just go right down through the middle, they also work as like just like a bar strap clamp. So say you had like clearance in a part, something like that, like some type of bore cut in it, you'd just be able to put the part over it and just work as like a bar clamp or something like that. So kind of versatile, just use them for a lot of different things. They don't take up much space in a drawer. Something that I was always doing too is all my base plate work. Because of having all the different clamps that work with the 1032, I essentially just always keep like a drill and a tap setup so I could just tap a 1032 anywhere and then be able to give myself a way to like fixture something. And like a 1032 being, you know, a much smaller hole, so it takes up much space, you need less room for it. It's just kind of easier to put in something than like your big half 13s or something like that. So running our tap again. And it just happened alone, and it is a newer tap, but I haven't had any, you know, the tap seems to be going really well in the machine using the rigid tapping, getting good performance out of it. Same type of tolerance and fit in every single hole that I'm checking, so that's always a good thing. Well, and see, that one right there, I pulled the part out early, but I already got my tap in there. So with what gets left, with what's needed to still be done on the part, I should be able to still reload this and be good. We're just going to try it. That was the only thing I was worried about before, is when I was accidentally making that mistake, I had not ran the tap, so I didn't want to try to run the tap back into the part. But with the tolerancing of the part, if that slot is a little bit off an X, or like the wall a little bit, it's not going to really affect the functionality of it. And those pre-drilled holes are just kind of clearance for the end mill, so the end mill should still be able, the end mill should be able to perform even if those holes weren't in there. It's just kind of relief to be able to make it run, allow it to run faster. So now this is going at 140 inches a minute. Yep, still trucking through there just fine. And then right after this part, just because we only got like 10 minutes left, I want to make sure I jump over and reference fusion a little bit. Just because I said I would at least reference that. And this will kind of do our, this will be our 200% test anyways after this part. So this will be pushing the maximum feed rate of the machine, which is like around 300. So not this facing cut, but when it goes to do this ramping, it should be trucking pretty fast. Essentially, that's almost like a, this cut is pretty much at like the full rapid speed of the machine. Oh, did my video stop on the one? Maybe came unplugged here. Give me a second. I'm going to redo it if I have to. Oh, we got the delay on the one video here, so let me try to reset that for a moment. But yeah, I'm gonna reference Fusion for a second anyway, so we should be able to get this other camera set back up while I'm referencing Fusion. Give me one moment. And I'll be able to, I can reset it here when I go to reference Fusion here. So let me get this off of the screen here. Alright. So I'm going to just pull up Fusion here. Give me a second. I want to make sure I got the right screen up. Was it a display capture or video capture? Oh, sorry. Or my display went away. Thought it was on top. Oh, there it goes. Alright, so yeah, here's the part that we actually got running over in the machine. So I got some little fillets that I designed on the outside of it, kind of some chamfers, the chamfer there. So you can tell even the part I got in there, I didn't go as deep for the chamfer for how I programmed it. I kind of just did the model like that. And something that I did with how I designed actually this part is I purposely left the bottom of it kind of flat like this, so I had my clean geometry for being, like if I wanted to just grab that outside profile and everything like that, it just gives me a little bit of like a cleaner geometry to work with. And then I have all my saved, I have like saved features in my tapping here, so just goes to shows the order of it. It does the spot for the tap, spots the other 2 holes, the 2 different drills. I'll try to reference it better. So we got spot, drill, does those 2 drills. I'll reference the part in the correct orientation to the machine. So then it comes in, does the tap, does the contour, which is the ramping, comes in, does the face of the part, does a chamfer, or does the contour on the outside. And if you actually see, I actually noticed this in the machine, and I noticed like when I did my facing, I didn't go far enough here to where it left that little wall there. But because my chamfer is deep enough, once I actually run my chamfer, it goes away anyway. So I didn't have to like go make any type of adjustments or anything. It just kind of removed it. And you can see how I got it programmed here. I just got that chamfer to there, how it kind of is in the machine. So I just wanted to reference some of those. And again, if you wanted to like go and increase the speed rate or the feed rates and everything like this from this program, you just go into like edit tool here, go into your cutting data, where I got 20s and stuff set here. I could just go increase those to 40 and stuff like that if I wanted to go into like the 200% range. Let me just reset up this one camera again here. Give me 1 second. And then we're good to go again. Put this one back in the front. A little bit of on-the-fly adjustment, but do what you gotta do. All right. So yeah, I just want to always be able to reference that fusion and stuff like that. Do you pre-drill the slots for chips for evacuation? Kind of both. So yeah, it's kind of that relief too. So like when the tool actually gets into where it's like taking that turn and getting into that corner is where it's kind of like the most tool pressure and everything like that. So it's kind of just relieving that tool pressure because it's the slot's only like 195 wide and the tool's only a 3/16 end mill. So it's almost just like full slotting right through it. So it's kind of just having that relief. But it does help for the chips too. Again, where it's kind of just that plunging and just overall tool pressure relief. So as it's getting to each hole on each side, it's also relieving a little bit so it's not like fully engaged in the cut. It's kind of like almost think of it like a chip break with pecking a drill or something like that. So where was I in here? Okay, back to my tool 1 for my chamfer. I think we got just checking that I had feed rate or feed in the machine again. All right, run my chamfer 200% here. Yeah, because that chamfer is going 80 inches a minute around the part there now, so. And yeah, you can see a little bit of lines from how it does it, but again, for what we're doing, it's still a completely fine finish. And that's the nice thing with designing your own parts and everything like that, is you get to control the finish and the tolerancing and stuff like that based on the function of what you're creating it for. Where, like I said, right now, I got a little 440 at home and like these clamps in, so I can even reference it here. We have like little T-nuts and everything like that for our 440, but they're for a bigger size screw and everything like that, and they're designed to be essentially like the maximum size screw that can work with the T-nuts in the machine, but I just want to be able to make some T-nuts that have a 1032 clamp to just, again, be able to, I can essentially just have a bunch of different length screws then for all my setups, and just know that it's all the exact same type of screw, and I only need to have like that one tap set up for, getting something set up for all my clamps. So we're gonna go turn that drill into a G81 now. So we're actually just gonna go into the program here. I'm just opening up the file. I'm going to do edit G code. It's just going to pull up like a notepad file over here. That's all that's on the screen. Going to go to the top of it with I know the drill is right at the front of the program. So let's see, we got our G83 here, which is our PEX cycle. So we're just going to turn that into a G81 and remove the Q. Okay, where was that one? Oh, and I just noticed that I still had I forgot I had 2 drill cycle there and I only changed the 1 earlier. So I'm changing that as well. Feed rate 10. Take out the Q again. Had to make both of the drill cycle the G81 there. So now we got that done. Oh, looks like my computer came unplugged somehow. Okay, we're gonna close this out. Oh, and then we got an error from how I just edited it. So it's always something to be careful about when you're editing G-code by hand. I'm just gonna go make sure I look at what I just did. G81, 81, 0. Let's see here. What are we getting for my error? Bad format. I can always just go, okay, so we got it right here where it's telling me my error is. Oh, it looks like I got 2 decimal places in there. So something as small as that will actually give you an error on that. So right here, after my feed rate of 10, I accidentally put in 2 decimal places. Again, one of the risks when you're actually editing by hand. Should be good now though. All right, got my tool 1 in. Got my part locked in. Then we're going to be good to go. We're at 200. And then the real change here should be on this next tool. It's going to be the drill. That should just be a straight plunge through the material now. Make sure, just because I made, again, changes by hand, I'm actually going to watch this a little bit more carefully. Yep, did it just fine. So yeah, that increased the speed of that tool like pretty significantly just by doing that. It looks like we're hitting 3 o'clock here, so unless anyone has some more questions or would like to see anything specific, going to be kind of ending this here pretty soon. Maybe the next time that we get in here, I'll kind of have the second op done on these, be able to show that, maybe kind of do the T-nuts that I was talking about for the next reference, kind of show that. And then we got a 440 right over here as well, so the stuff and the clamping on how I'm talking about using it on the 440, I can probably take the stuff over there and reference it next time I get on here and kind of show how some of these clamps are actually used. So again, until next time, it was nice talking with all you guys, and see you guys next week.